Welcome to Kenton Teaches. Enjoy the video.
You start by confirming the unit and power. If mechanical, lock the dial. Enter the true airspeed or ground speed and set the wind mark. Align the wind direction, shove the grommet for wind speed, and read the drift mark. Once done, set the true course across the center line so you can reference it quickly. You do this to establish both heading correction and ground speed baseline. This initial alignment saves time when you move to wind correction and fuel planning. You now compute wind correction and heading. Rotate the wind vector to intersect the center line and read the WCA where the drift mark sits. Apply the WCA to your true course to get the corrected heading, then convert heading to magnetic by adding or subtracting variation. Once done, shift to the speed scale and read the resulting ground speed under the true airspeed marker. This sequence tells you how and why your heading differs from course and yields accurate ground speed for time and fuel calculations. Finish by calculating en route time and fuel. Divide leg distance by your ground speed to get minutes. Multiply by fuel flow to obtain fuel required and add reserves. Then verify performance effects. If temperature or altitude changed, recompute density altitude and adjust speeds or fuel numbers. If values look wrong, troubleshoot systematically. Re-enter wind direction and speed, realign the center line, and confirm you used knots versus miles per hour and applied magnetic variation correctly. This fixes most common errors quickly.
Thanks for watching. Please subscribe if this video was helpful.